ऑल राइट, शुरू करते हैं पीरियोडिक टेबल यानी कि क्लासिफिकेशन ऑफ एलिमेंट्स एंड पीरियोडिसिटी इन इट्स प्रॉपर्टीज के एग्जाम्पलर के सवाल काफ़ी डायरेक्ट हैं, बट दीज फॉर्म द बेसिस ऑफ एवरीथिंग इन ऑर्गेनिक केमिस्ट्री, सो मेक श्योर ये करो बिफोर यू डू बॉन्डिंग एंड एवरीथिंग इन पी ब्लॉक एटसेट्रा। काफ़ी सिमिलर हैं। पहला सवाल, कंसिडर द आइसोइलेक्ट्रॉनिक स्पीशीज, 4 दिए हुए हैं, करेक्ट ऑर्डर ऑफ इंक्रीजिंग लेंथ ऑफ द रेडियाई। ओके, रेडियाई ज़्यादा क्यों होगा? वेल, अगर इलेक्ट्रॉन ज़्यादा हो गए, बट इलेक्ट्रॉन सबके सेम है, अगर इलेक्ट्रॉन सबके सेम है तो जिसमें प्रोटॉन्स ज़्यादा होंगे उसका साइज कम हो जाएगा, राइट? दैट्स व्हाट यू गोइंग टू यूज। सो प्रोटॉन ज़्यादा साइज कम, प्रोटॉन ज़्यादा साइज कम, प्रोटॉन ज़्यादा किसके हैं? इसके सबसे ज़्यादा। सो देन दिस शुड बी द आंसर, राइट? मैग्नीशियम, या दिस मेक सेंस टू मी। देखो, ऐसे इलेक्ट्रॉनिक मतलब सेम इलेक्ट्रॉन्स, प्रोटॉन्स मोर, साइज स्मॉल, 1 शुड बी 2। लेट्स मूव ऑन। Which of the following is not an actinoid? Actinoid. I think ये वाला, right? ये वाला lanthanide हो जाएगा. Let's move on. Directly periodic table से. If you're like, what? Where? Open up the periodic table. Ta-da! That's the beautiful thing about this. ptable.com, just where you're at. ये सब हो गए तुम्हारे नीचे वाले lanthanoids, ये वाले actinoids. Which one was that? वहाँ पे कौन सा वाला लिखा था? Wait, let me go back and see that. This was terbium हम लोग देख रहे हैं, मैं सिर्फ नंबर देख रहा था, इससे मुझे भूल गया था कि which one it is. Terbium कहाँ गया? There you go, right in the middle, 65, right? Okay, ठीक है, let's move back. We'll keep referring to this awesome web page, which is ptable.org while we do this. Okay, let's get back to question number 3. The order of screening effect of electrons S, P, D and F of a given screening effect किसका सबसे ज़्यादा होता है? Well, screening theory is this, right? If the orbital is well defined, it will screen the things that come after it nicely. Well defined सबसे कौन सा होता है? S orbital, तो उसका सबसे ज़्यादा screen effect होगा then P, D and F. This is direct theory. We're not going to spend time too much on this. Next question, the first ionization enthalpies of Na, Mg, Al and silicon. Now, this is directly from data. Okay, first ionization energy should be the least for sodium, है ना? क्योंकि उसको निकालोगे तो it forms what should I call it? Your good old noble gas configuration. So, ठीक है, let's remove this and let's remove this. Between 1 and 3 कौन सा होगा? And this one's a little hard. I don't know if it's that direct, right? Because magnesium technically is a S2 species, so you can argue a lot about it कि ये हो सकता है, वो हो सकता है. But the safest thing to do, as always, look at data. Now, technically, you could also look at the NCERT itself to figure this out. But hey, since we have this awesome site open, we can also go here. Ionization enthalpies आप देखिए, and the highest one among these, happens to be for silicon, right? Silicon का सबसे ज़्यादा है, but magnesium is greater than that of aluminum. You can see that, right? Mg का value right here, 737 है यहाँ पे, sodium is 495, सबसे कम उसका. So there you go. As you predict from theory कि S2 configuration की वजह से magnesium का ज़्यादा है, just a little bit under silicon. Silicon is 786. Okay, cool. Let's move back to this thing here, and कहाँ पे था? Option 1 should be the answer. Be careful about this. Okay, चलो आगे बढ़ते हैं. The electronic configuration of gadolinium. अरे I think almost exactly ऐसा सवाल आया था in JEE 2024 JEE main Jan attempt में. And electronic configuration क्या होगा? 64. Okay, I think what you need to do is figure out nearest noble gas क्या है. 64. Is it 56? Is it 58? I think it's 56, right? Or is it 54? I think it's 54. Yeah. How do you remember? Well, 36 plus 18 gives you 54. If you don't remember 36, well, you should. उससे पहले आता है 18, right? उससे पहले आता है 10, उससे पहले आता है 2. So 2, 10, 18, 36, 54. This I remember. तो 54 plus 10. अब इसमें सब में plus 10 आ रहा है क्या? Great. No. ये तो ज़्यादा हो गया. Let's cut this one out. Xenon should be 54. You want to check? Let's quickly check. Let's go to this side. And you can clearly see कि ये यहाँ पे है आपका xenon, which is 54. Okay, you're studying the periodic table, so you got to have it open while you're doing this. ठीक है. One moment, let me get to the right page. Okay, so there you go. That was 54. तो ठीक है. Plus 10, ये तो 10 से ज़्यादा हो गया. 7, 8, 9, 10, 7, 8, 9, 10, 7, 8, 9, 10. Now what do you do? Well, this one doesn't make any sense. 5D 5 क्यों जाएगा? You know that it is either 6s or 5D में 0 to 1 होता है. 6s is usually 2 itself, है ना? तो now I have to figure out इन दोनों के बीच में कौन सा होगा. And this is a tricky thing. It's either you know it or you don't from here. मेरे हिसाब से it should be 3. What do you think? आप चेक करके देख लो. मेरे हिसाब से तो यही होना चाहिए. Yeah? Because 5D 0 to 1 and 6 is 2 is the usual configuration, which means 3 should be the answer. The statement that is not correct for periodic classification elements is what? Property elements are periodic function atomic numbers. Yeah, this one seems okay to me. Non-metallic elements are less in number than metallic elements. ये भी सही बात है, ठीक है. For transition elements, the 3d orbitals are filled with electrons after 3p and before 4s. ये थोड़ा अजीब लग रहा है. Let's read the next one. The first ionization enthalpies of elements generally increase with increase in atomic numbers. Yeah, first ionization generally increase in atomic number across period. Yeah, generally increase, but there's a dip, right? आपने देखा था कि एल्यूमिनियम में थोड़ा कम हो गया था. That was an exception or that. So when you're in a test, right? Test taking tips है. So it's okay if there's a long sentence that you don't comprehend, skip it, go to the next one, because elimination say you can figure that this is the one that's the incorrect answer because you got to find out not correct, right? So sometimes that's also a thing to do, speed reading. Let's analyze this one though. For transition elements, the 3D elements orbitals are filled with electrons after 3p and before 4s. See, this before after वाला चीज ना वो हमारे दिमाग में है. I know, according to the n plus L rule of power principle and all of that, this is clearly false. But this concept of filling, ये हमारे लिए है to justify what is happening at the atomic scale. Think about it. जब तुम इलेक्ट्रॉन निकालते हो, obviously सबसे outermost इलेक्ट्रॉन निकलेगा. निकालना मतलब ionization energy. So you're going to remove the 4s electron first. But while filling, theoretically, 3d gets filled first, then 4s. 3p obviously not this thing. Yeah. पहले 4s भरेगा, उसके बाद 3d. मैंने उल्टा भी बोल दिया ना. 4s पहले, then 3d, because 4 plus 0 is n plus L इसका, and 3d is 3 plus 2, I want to say 5. So इसके n plus L value is 5, which means it is of higher energy than 4s. So it will get filled afterwards, which is why electronic configuration होता है 4s2, 5d, 3d, 1, 2, 3, 4 for all of this. आप ये theory जानते हैं, but I wanted to spend some time on this. I know I may have confused you a little bit by saying कि अरे एनर्जी तो ऐसा होता है वैसे होता है. देखो एक्चुअली क्या होता है, तुमको इलेक्ट्रॉन निकालना है, निकालने से निकलेगा 4s से पहले, बट भरते वक्त 4s will get filled first. Okay, some students have a difficulty understanding. Please ध्यान से theory पढ़ लेना. Among halogens, the correct order of amount of energy released in electron gain enthalpy is what? Electron gain enthalpy क्या होता है? और एक और दूसरी इलेक्ट्रोनेगेटिविटी. ये दोनों के ट्रेंड्स थोड़े अलग आगे पीछे थे. इसमें थोड़ा सा sometimes there is some confusion. Okay, let's see क्या होता है. I know that electron affinity, electron gain enthalpy same है क्या? Let's see. साइड पे देखते हैं, इस साइड पे क्या बोला है यहाँ पे, ठीक है. Options में if you go in this thing on the left, you don't really see electron gain enthalpy, just electron affinity. So they're the same thing, it's just a sign that is different. And you can clearly see कि chlorine की value सबसे highest है at 349. Okay, अगर थोड़ा छोटा और zoom करके देख लो और just log it by yourself. Fluorine is 328, bromine is 324. ये सब चीज़ आपके NCERT में भी है, of course. But hey, I like this cool thing, so मैं इसको खोल रहा हूँ. You can open the NCERT and study this by yourself. So Cl is the highest, and then बाकी these guys fit in this order. Okay, so 3 is the answer here. But I know ये थोड़ा confusing लगता है when you have these brackets like this on both sides. It's a little confusing, but this is the right answer. The period number in the long form periodic table is equal to, period number is n, right? मैं option देखने की जरूरत नहीं. n was the principal quantum number. Maximum, yeah, maximum, ठीक है. 8-3, yeah, shall we move on? Okay. 9th one, elements in which electrons are progressively filled in 4f orbital are called transition elements. No, of course not. Lanthanoids. Wow, okay. This is, periodic table, one of those things that really saves you time for physics and maths. This is one of those chapters, right? Chemistry, maybe either you know it or you don't. Which is the following correct order of size of given species? Well, I minus सबसे बड़ा होगा, I बीच में और I plus सबसे छोटा, I think. So 4 should be the answer here. Why? Because well, number of protons is same. Electrons बढ़ा रहे हो तो size बढ़ जाएगा. Electrons घटा रहे हो तो size छोटा हो जाएगा. Because protons is same. Okay. The formation of oxide ion, मतलब कि O2 minus from oxygen atom requires first an exothermic and then endothermic spec. Wow, interesting. Thus, the process of formation of O2 minus in gas phase is unfavorable even though O2 minus isoelectron neon. ये क्यों हो गया? अरे एनर्जी के हिसाब से तो लग रहा है तो नहीं होना चाहिए O2 minus, but you know that the ion exists as O2 minus. आपने काफी जगह देखा है इसको. Oxygen is more electronegative. Addition of electron in oxygen results in larger size of ion. True, maybe, but that's not reason. Electron repulsion outweighs the stability gained by the achieving noble gas configuration. Okay, electron repulsion outweighs stability. तो ये बता रहा है कि process of O2 minus in gas phase is unfavorable. Remember, gas phase की बात हो रही है. Okay, बिकॉज देखो एक इलेक्ट्रॉन ऑलरेडी डाल चुके हो, एक एक्स्ट्रा इलेक्ट्रॉन है, छोटा सा है ऑक्सीजन काफी, राइट, इट हैज व्हाट हाउ मेनी 8 प्रोटॉन्स एंड नाउ 9 इलेक्ट्रॉन्स, एक इलेक्ट्रॉन ज्यादा आ गया, सो इट पुशेज इट आउट मोर, या इलेक्ट्रॉन रिपल्शन आउटवेज द स्टेबिलिटी. आई थिंक दिस शुड बी द राइट आंसर. Check out the NCERT theory if you want, but this should be O minus has comparatively smaller size, has a larger size. ठीक है. Comprehension, बड़ा सा comprehension, element atomic number 57. I'm not even going to read it. We'll see. 56 plus 1, but that's not the right thing. It's 54 plus 3. This belongs to P block. Yeah. Let's see if we need to even read it. Sometimes, and I'm being a little cheap here, sometimes you get away with not even reading it. But is that correct? No, hold on. 57 is P block? No, it should not be P block. It is D block. If it's, देखो 54 plus 3 तो सही है, but yeah, this in this case right here you're going to have, क्या बोलते हैं इसको, 3D gets filled before, or even whatever D it is, D gets filled before P. Huh? Why? Does that make any sense at all? Wait, P पहले भरना चाहिए ना. Well, think about it, right? If I've got this D block element over here, which D is it going to? I think let's open up the periodic table to understand कि क्यों ये सही है. बाकी तो तुमको बस कहानी बता रहे हैं ऊपर ऑफ प्रिंसिपल नॉलेज. यू कैन रीड दिस टेबल इफ यू वांट. हियर आई थिंक द ओनली कंफ्यूजन आई हैव इज इट पी और इज इट डी ब्लॉक. लेट्स ओपन अप द पीरियोडिक टेबल टू गेट आउट ऑफ दैट कंफ्यूजन. कभी भी नहीं होना चाहिए ये चीज, बट ठीक है, अगर है तो इट्स अ गुड थिंग टू. 54 इज राइट हियर, ठीक है, जेनॉन. उसके बाद तीसरा कौन सा? ओ माई गॉड, इज इट going to get even more confusing? Oh, I think I know what I did. I just extended this and it became a little weird. Let me go back to that. How do I go back to the shorter form of the periodic table? Okay, I'm just going to refresh the page. There you go. Because otherwise I'm hiding a little bit of your screen, right? Okay. So barium is 56 and 57. 57 is lanthanum. अब इसकी electronic configuration क्या है? Well, it's interesting here because it says that the energy level is 9 and 2. What on earth does that mean? Well, what you're doing is you're filling, this is 3D, 4D, 5D. Okay, so 5D में जा रहा है electron. So this is the first of the 5D series, not the 5P series. That's right here. 5P तो helium है, right? Look at this. Look at the periodic table. You get it right away. And this is, what is this? Is this 4F? Yeah, this is 4F. This is not 5F. This is 5F. This is 4F. Okay. तो इसको देखने से directly तो it seems like this is getting very hairy. So you need to know what the periodic table looks like and where is D, where is F and all of that. P and S are easy to understand, right? But D and F कौन सा कहाँ पे जाता है, थोड़ा practice आ जाएगा. So this is 3D, 4D, 5D. Okay, vanadium, niobium and tantalum. Okay, cool. So 5D में ये electron गया, 57 में specifically lanthanum. Hence you say that it's a D block element. That's it. This is more about understanding the periodic table and comprehending it, not understanding. मतलब ठीक है, दोनों same शब्द हैं, but theory है boss. That's what I'm trying to say. ठीक है, and it's not P block. I know मैंने भी गलती से शुरू से P block बोल दिया था, but we checked. Oh wait, hold on. Let's look at the periodic table. Always do that जब सीख रहे हो तो. टेस्ट में तो नहीं देख सकते हो, but सीखते समय तो देख सकते हो. The last element of the P block in 6th period is represented by the outermost electronic configuration. 6th period. 6th period मतलब कि n value maximum हो सकती है 6, right? That's what this means. So you remove the ones that are 7. So it is either this or it is this. Last element of P block must be 6P, 6. Yeah, think about it. I think it should be this, just from this. Which elements whose atomic numbers are given below cannot be accommodated in the present setup of long form periodic table. Present setup. I think 126 because then you're out of all the 5F things also, right? So I think it should be this. I'm not going to spend too much time on this one, but I think it should be this as well. The electronic configuration of the element which is just above the element with atomic number 43. Just above 43. Just above 43. Can we do 43 minus 18? What does that give me? That gives me a 5 and a 2. It's 25. Wow, 25 is a beautiful number. 25 looks like it's a 3D element, right? Because 18 plus 7. 18 is my noble gas. 18 plus 7. मतलब 2 चले गए. 3, 5. This is manganese. I think so. Manganese होना चाहिए. 3D5, 3D5, 3D5. This is an answer according to me. What do you think? That's how we do this. That's how we do this. Why did I subtract 18, not 36? Well, because obviously there is no F block element. अगर F block element होते, then I would also have to account for 14 of those, right? Khair, we're not doing that right now, so let's just subtract 18 and be happy. and 36 subtract करने का मतलब नहीं है, right? I said 36 would be a mistake, but 18 comes from S plus P plus D. If you have plus F, that's another plus 14. Okay. How? 2, 6, oops, and 10. ये हो गया 18. अगर ये जल्दी, if that went too quickly, that's why we did that. Okay, cool. Move on. The elements with atomic number 35, 53, 30, 85 are all. Just because I know 35, I'm going to say this is chlorine. But this is basically 36 minus 1. This is 54 minus 1 and 86 minus 1. देखो यहीं पे ये चीज़ figure out हो गई. 54 plus, how much is this? 30, no, not 30. Yeah, it is. It's 32. Was that a right number? Yeah. 18 plus 14 is 32. जो मैं exactly आपको ऊपर बता रहा था, है ना? 18 for SPD and F के लिए plus 14. So, these are all noble gases. 86, 54 and 36. उससे एक कम, मतलब ये सब होंगे halogens. आहा, wonderful. ये planted नहीं था जो हमने actually अभी theory की करेक्टली आ गई. अरे तो काफ़ी दिलचस्प हो गया ये P block वाले, not P block, but periodic table वाले सवाल. I didn't think it would be this much fun. I thought ठीक है होगा कुछ boring चीज़, but मज़ा आ रहा है. I hope आपको भी आ रहा है. Electronic configuration of 4 elements are given below. Which of the following is the correct order of increasing tendency to gain electron? मतलब electron gain enthalpy. ठीक है. किसकी सबसे ज़्यादा होगी? इस भाई साहब की. 2p5. D is going to be the maximum. What do you think? Do you agree with me that D has to be maximum? Because halogen. सबसे कम किसकी होगी? एक ही. चलो. That doesn't say, help us in any way. इसकी भी काफ़ी कम होगी after noble gas because, well, it's a metal. 3s1. S1 is a metal. It does not want electrons. So metal के बाद AC. So I think it should be 13-1. Okay. With that, we're done with the single correct ones. Let's go to multiple choice questions type 2, यानी कि एक से ज़्यादा correct हो सकते हैं. Which is the following elements can show covalency greater than 4? Phosphorus obviously gives PCl5 and all that. Sulfur and not these guys. Yeah, you know why. We don't have D and all of that. ठीक है. D नहीं है तो इसकी वजह से empty d orbitals नहीं है, so you cannot form multiple valencies, right? And also larger valencies than 3, larger valencies than 4. All right, 15th question. Those elements impart color to the flame on heating on it, the atoms of which require low energy for ionization, absorb energy in visible range of spectrum. Elements of which of the following groups will impart color to the flame? Well, first and second groups. 15-1, 15-3. चलिए आगे बढ़ा जाए. Which of the following sequences contain atomic numbers of only representative elements? Now, ये representative elements क्या बला होती है? I think it is S and P and not D and F. It's literally as simple as that. ठीक है. तो with that in mind, I think if you look at it, S and P होने चाहिए, right? Let's find some D block elements. This has a D block element, 25 manganese. Let's remove that. 88, 86 plus 2. Well, kind of works. तो ये भी है. What about this? This one a little hard because you need to know where is a D block element and where not. Contain atomic. Okay, this one is doable. I think 33 is आपका था 20 plus 13. I think this is a D block element. I'm not sure. I'll have to check. I think this is a D block element. No, it's not. 25 is D block. 30 is zinc. Is 30, right? Oh, then we are good. We are good. This is beautiful. This one works, right? Ye has only S and P. In fact, I think all of them are, yeah, S and P. Okay, great. 2, 10, 22, 36. 22. Odd person out. So answers are this and this. You want to check 35? 35 is chlorine. 51 is 54 minus 3. So P block ho gaya. 88 is 86 plus 2. Okay, lovely. These two. Which of the following elements will gain one electron more readily in comparison to the other elements of the group? More readily matlab must be P block jiska electron gain enthalpy zyada hogi. Ta-da! These two. 17, 3 and 4. Wait. I remember that there was some exception here. Do you remember this? Because oxygen काफी छोटा है, उसको electron मिलना थोड़ा सा complicated है. I know that oxygen gaining one electron is easier than the second electron. वो अलग चीज़ है. But between oxygen and sulfur, I have a feeling that sulfur has a lower value or a higher value of electron gain enthalpy, and hence it easily accepts an electron. चलिए periodic table फिर से खोलते हैं. आप NCERT में भी आसानी से देख सकते हैं. What we're looking at, not ionization enthalpy, we're looking at electron affinity. देखो कहाँ गया तुम्हारा, देखो sulfur is 200, whereas selenium is 195. They're all small. And in fact, oxygen has the smallest electronic enthalpy. It really doesn't want an electron as compared to sulfur and all of these guys. Wow, polonium will all rather get an electron than oxygen. But still, O2 minus exists. It's very interesting. Nature is बहुत amazing है. But sulfur should be the option that you select along with chlorine and not oxygen. I know you may be tempted to do oxygen. This type के सवाल can really trip you up. Yeah, man, this chapter में you've got to know the theory inside out. There's no other way to do this. Which of the following statements are correct? Helium has the highest first ionization enthalpy in the periodic table. Highest first. This sounds about right actually. I think it does, right? We can look at it. Theory देख लेंगे. I think it does. Chlorine has less negative electronic enthalpy than fluorine. Less negative. No, it's more negative. 349. More negative, right? We just did that. But if you didn't, वो देख सकते हो. Mercury and bromine are liquids. सही है. Any period atomic radius of alkaline metal is the highest. Alkali metal का yeah. As you go from left to right, radius decreases. Perfect. तो अरे इसमें 3 सही हो गए. देखना ये वाला. चलो देख लेते हैं. Let's go here. And you can see क्या हम लोग देख रहे थे हीलियम की इलेक्ट्रॉन अफिनिटी नहीं हम लोग देख रहे थे आयनाइजेशन एनर्जी 2372 दैट्स द हाईएस्ट अक्रॉस द होल पीरियोडिक टेबल. थोड़ा सा टाइनी हो गया है बट यू कैन डेफिनेटली जस्ट गेट दिस राइट ptable.com that's what you got to go. Okay, let's get back to the exemplar questions. Which of the following sets only contains isoelectronic ions? Aluminium? No, I think it's aluminium. Zinc and all are good, but aluminium? Gallium? No, these two are different periods. Well, that could work, but they are the same group. Different periods is not a problem. The same group, different periods, that doesn't make sense. What about this? Sure, they are, even these, this set and this are different periods, but they are, wait, sochne calcium, no, potassium, calcium are 19, no, 20, wait, potassium? Nice, sodium, yeah. This again is an odd thing out, right? I was like, hey, this is an imposter. If Na plus hota, then that would work. But nope. Then what about this then? Phosphorus, sulfur, chlorine. This looks good, right? Yeah, dono different periods, but same number of electrons. I think this one works. 17, 18, 19. Yes. Potassium is 19 and then calcium. Hey, hold on. Sodium. No, this was also correct. Then 2 and 3 are both correct. Hai na? 2 and 3 are both correct. If 3 is correct, 2 has to be correct. That was a brain freeze moment. Then ये वाला तो गलत है. What about this? Chromium, vanadium ठीक है. Argon, titanium. यार ये भी सही लग रहा है. Hold on. इसको ध्यान से देखना पड़ेगा. Let's not do this in a hurry then. If 2 and 3 are correct, ये फिर सही क्यों लग रहा है मुझे? But also at the same time दाल में कुछ काला लग रहा है. Oh, I'll tell you क्या काला लग रहा है दाल में. This is not a D0 configuration, right? This is D0, this is D0, and so is this. But chromium 3 plus has electrons, has D electrons, right? It has 3D electrons, 3D3 literally, है ना? Or more in fact. Okay, you want to do this? 24. 24 is 18, which is argon, right? उसके बाद 3D something 4s1, 3D5 4s1, right? उसमें 3 निकाल लोगे. Oh, तो सही था 3D3 हो रहा है. Yeah, so no, that's why this is wrong. ध्यान से करने वाली चीज, not in a hurry. Which of the following options order of arrangement does not agree with the variation of property indicated against it? Increasing ionic size. Increasing ionic size इसका सबसे ज़्यादा है और उसका सबसे कम है. This seems okay. Not करना है. Increasing first ionization enthalpy. First ionization enthalpy इसकी तो काफ़ी कम है. Ionization ionization मतलब कि इलेक्ट्रॉन निकालना. इसको सोचना पड़ेगा. This one is, I feel this one should be the highest. Yeah, because that's a P3 configuration. Hence ये गलत है, which means we would want this to be the answer, right? More than one correct and does not agree. Chlorine has the highest EGA, hence ये वाला गलत है. This should be here. Li blah 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 blah. Increasing, yeah, sure. Okay, great. 2 and 3. Which of these has no unit? Electronegativity unit होती है, याद नहीं आ रहा है. इसकी तो है. Iron enthalpy की इसकी भी है. Both are energy. Metallic character, yeah. So 1 and 4. 1 and 4. Ionic radii vary in inverse proportional to effective nuclear charge. Effective nuclear charge अगर ज़्यादा हुआ तो radius कम होगा. Kind of makes sense, but सोचने दो. Kind of makes sense to me. I think this one's right. Inverse proportional to square effective. What? This is so random. Inversely proportional to square of, okay, actually theory you need to know to do this. It's not that direct. Yeah, it's not that direct. You have to know this, that it's either 1 or 2. Okay, direct proportional to screening effect. This also looks good to me. अगर screening effect ज़्यादा है तो फिर radius जो है कम हो जाएगा. अगर screening effect बिल्कुल नहीं है तो radius बढ़ता जाएगा, है ना. F is diffuse so it doesn't have a good screening effect. मतलब कि wait, hold on, उल्टा बोला. अगर screening effect ज़्यादा है तो मतलब कि it screens the outermost electrons well. अगर screening effect कम है like F, तब छोटा हो जाता है. तब तो ये गलत हो गया ना. 22/3 should be wrong. What do you think? Direct proportional to square of screening effect. This one's a tough one, man. I think इसके लिए हमको NCERT खोलनी पड़ेगी. So let's circle back on this once we open NCERT. Yeah, we can't do this without the NCERT. An element belongs to third period and group 13 of the periodic table. Which of the following properties will be shown by the element? Third period and group 13. Aluminum की बात हो रही है क्या? Good convexity, solid, metallic. Yeah, aluminum की बात हो रही है. You don't trust me? Don't have to. Let's go to the site. Third period, group 13. Third period, group 13. Okay. Period number 3, which is sodium का period, group 13, यानी कि aluminium. Tada! Okay. Beautiful. Okay. ज़्यादातर हो गए हमारे सवाल. Now let's see. The only thing that's remaining is assertion reason, because that's what we write. हम लोग वैसे सवाल करते हैं JEE NEET में आ सकते हैं directly. Assertions correct. 4 टाइप की चीज़ें ठीक है. Assertion. Boron, no. Generally, ionization enthalpy increases from left to right in a period. Generally, ionization enthalpy increases from the left to right. Generally, सही बोला. I agree. Generally, that is the case. There are exceptions because it's chemistry. When successive electrons are added to their orbitals in the same principal quantum level, the shielding effect of inner core of electrons does not increase very much to compensate for the increased attraction. ये भी सही लग रहा है, but how the two related? Let's read it one more time. When successive electrons are added to the orbitals, okay, करते जाते हो, shielding effect of inner core of electrons does not increase very much compared to the increased attraction of the electron core of nucleus. Yeah, but I don't think the two are related. So both are correct, but I don't think they're related. What do you think? If you think strongly they're related, let me know in the comments why. Boron has a smaller first ionization enthalpy than beryllium. Oh man, you're gonna have to look it up. The penetration of, can we do this from periodic table का atomic structure का idea? Hydrogen, helium, lithium, beryllium, boron. Okay, so this is 1s, 1s2, 2s1, 2s2, 3s1. So beryllium से निकालना ज़्यादा मुश्किल होना चाहिए, है ना? That's what it's saying. सही लग रहा है मुझे तो ये वाला part. Okay. And what is happening here? The penetration of a 2s electron to the nucleus is more than the 2p electron, hence 2p electron is more shielded by the inner core of this thing. Okay, the penetration of 2s electron is more 2p electron is more shielded by the inner core. Yeah, सही है. तो दोनों सही हैं and reason भी सही है. Now be careful over here. It looks like the reason and assertion are correct. That's cool, but the options are jumbled up, right? उसकी वजह से ये भी कारण सही था. I'm sorry that I bundled this up, but yeah. This is the exact reason as to why this is correct. Got to be careful there. Electron gain enthalpy becomes less negative as we go down the group. Electron gain enthalpy becomes less negative. So many double negatives are hard to deal with, right? Electron gain enthalpy becomes less negative as you go down the group. Cool. Usually, but uska exception hai chlorine, right? Chlorine usually goes higher. But let's see, less negative. No, it should. Let's see. It's not always true. I mean, it's exception. हर group में exception है. Size of the atom increases on going down the group, and the added electron will be further from the nucleus. Size of the atom increases, you go down the group. Added electron will be further from the nucleus. Yeah, this is fine. Wait, so that would mean ionization energy कम होगी. Electron enthalpy से क्या? What is going on with this? So this is correct. For the assertion, I think let's open up the periodic table one more time. Okay, the question says electron enthalpy becomes less negative as we go down the group. चलिए देखते हैं. Let's look at the electron gain enthalpy वाला property on this P table. Electron gain enthalpy same as this guy. Okay, less negative. Yeah, it looks like it's becoming, yeah, 328 to 349, it's increasing, then it's decreasing. 141 is the least. In this case, it increases, then it decreases. 772 increases. Only in this case is it increasing properly. 153 कम हो रहा है, फिर और कम हो रहा है, फिर और कम हो रहा है, फिर और कम हो रहा है. Oh God, that's not great. And I think the reason why it's increasing in this is because it's a P3 configuration. And इसको चाहिए भी नहीं है, निकालना भी नहीं है, right? Doesn't want electron, doesn't want to get rid of. 2642 increases, decreases. So this is a tough one, to be honest, you know. इसको confidently बोलना कि it is either this or that is a little tough. So to be safe, I would say कि ये गलत है. But I think that this is a tough question. Who would have thought that a certain reason मुश्किल हो सकता है. But मेरे हिसाब से this is it. Okay, we had left one question saying कि हम लोग उसको NCERT में खोल के देखेंगे क्या हो रहा है वहाँ पे. Let's go back to that. Yeah, this is the theory right over here. So I think this is a very very straightforward कि ionic radii vary in inverse proportional to effective nuclear charge. मतलब कि अगर effective nuclear charge ज़्यादा हो जाएगा, जैसे कि for example, if you have isoelectronic species, calcium 2 plus is going to be much smaller than say chlorine minus, right? Chlorine minus is going to be much larger because effective nuclear charge chlorine minus का होगा कम as compared to calcium. Okay, screening effect, well, screening effect अगर ज़्यादा है तो फिर radius बड़ा हो जाएगा, है ना? Screening effect कम है तो radius कम हो जाएगा. It's similar to what you see in the atomic radius itself. So NCERT में there's just one line that says कि ionic radii is same trend as atomic radii. बस यही एक line लिखी है. I was like, oh, wait, hold on. Ionic के बारे में थोड़ा पढ़ लेते हैं, just to be sure. But this is all there is, right? So similar trend, मतलब this is the logic there. Okay, that's it. With that, we are done with the whole of periodic table. I hope you enjoyed this. If you have some comments on this or you have doubts, come on to the Discord server. Link है description में. I'll see you around. Bye bye.